Hi everybody, welcome back to AP Psychology with me, Miss Baines, your teacher, where you can take advantage of being able to pause and rewind me as I deliver you our latest content. So go ahead and grab those markers, get yourself nice and comfy, and of course don't forget those ever important binder notes that go in lockstep order with this video called Unit 5, Video 9, Assessing Intelligence, which can be found on page 20 of your binder notes. So moving right along in Unit 5, we're now going to talk about assessing intelligence, what some intelligence tests look like, and how we kind of figure out what that number is, and how that number has kind of evolved. And with assessing intelligence, we need to keep in mind some of those theories that we talked about in our last set of notes. So, psychologists define intelligence testing as a method for assessing an individual's mental aptitudes. And then, by comparing those mental aptitudes with other scores, that component, right, should be fairly obvious. But the comparing of it to others part is a little bit fishy at first. However, we're going to try and suss it out and get at what it means by explaining how it came to be, and each of the famous theorists who followed the other. Okay, so let's talk about the first one, Alfred Binet. Binet set out to find a child's mental age, or the average age of individuals who achieve a particular level of performance. However, it's important to note that Binet did not create this test to label children or put one higher than the other. In fact, he actually warned that if this information were misused, it would do just that. It would make people feel inferior if their IQ score was not normal or high enough. What Binet really wanted was a way to find and help improve the educational experience of French children, since that was where he was living at the time and doing his research. Some of the history and how the intelligence test has become what it is now includes how Alfred Binet and his colleague Theodore Simon developed the first standardized intelligence test. And we'll talk about that standardization part in a little bit. Fear not, it's coming. For the moment, though, it all started when they, meaning Simon and Binet, were commissioned by the French government to design a test to identify French children who would have problems with their regular everyday classes. Okay, so in their everyday classes of school, we kind of call this special education. They set out to find out what they referred to as a child's mental age. This definition is important, okay? So mental age is the average age of an individual who achieve a particular level of performance. For example, they might say this is what the mental age is of someone who at 6 should be able to do, okay? So if a child is actually 4 years old and they're able to do higher levels of problem solving than their same aged peers, then they're at the mental age of 6. It means that they are more intelligent or academically advanced. Again, Binet did not create tests to label children this way. It was not his goal. As I said before, he actually warned them if the information that he came up with were misused, it would make an entire generation of children feel bad about themselves. Next up was Lewis Terman in the United States. Lewis Terman, during his tenure at Stanford University in California, adapted and revised Alfred Binet's test for American school children. He named the test the Stanford-Binet IQ test. Fun fact, a form of the Stanford-Binet test is still in use today. Today, the Stanford-Binet IQ test is given orally and varies in nature according to the person who is taking the test. There's the children's version, in which they're given figures to copy or everyday problems to solve, and an adult form of the test, which asks the person to solve analogies, explain proverbs, and describe similarities that underline sets of words. The examiner begins by finding a mental age for a person, an age at which the person can answer all of the questions given. And then they move on to a more difficult set of problems when the mental age is reached, at which point no items can be answered, and therefore the test is over. Okay, once the person can't answer any more questions, you realize, okay, you don't have a mental age above that question. So now we know we have found your mental age a couple of questions ago. William Stern is up next. William Stern is the guy who came up with the intelligent quotient. That is the formula of the intelligent quotient, or IQ, which was introduced by William Stern, and he says that IQ equals your mental age over your chronological age, and your chronological age is how old you are in years, okay? Then he says to times that number by 100, and that is your IQ. However, it is actually no longer computed that way today. David Wechsler is a big name you need to know. David Wechsler, professor at NYU, instead developed the Wechsler Adult Intelligence Scale, or the WAIS, and later the Wechsler Intelligence Scale for children, called the WISC. WISC being an intelligence test for preschoolers, and it is that which they are most widely using in IQ tests today. Okay, so we have the Stanford-Binet, which is a form that is still being used, but the Wechsler test is being used much more frequently and widely throughout the country and even the world. So the WAIS measures overall intelligence. It consists of two parts. There's a verbal part and a performance part. The verbal being vocabulary definitions and comprehension, and then performance is the timed assembly of small objects and arranged pictures in logical order, like puzzles and stuff like that. So you're given an assortment of pictures and they might say, put these in logical order to make a story, or how are these words usually formed together to make a sentence. Normally, verbal and performance scores are very much within close range to each other, meaning the score that someone gets on those two are about the same. Yet, when you look at them separately, the scores can give you a more precise picture of a person's specific abilities, whether they be in verbal or in the logical performance piece. These are some WAIS examples. So for instance, the object assembly over here, they're asked to essentially put this puzzle together. That's what it is, right? They're asked to put this together, whereas the other ones are being kind of about that verbal piece, right? Let's talk about aptitude. Aptitude and achievement tests. Achievement tests are intended to reflect upon or measure what you have already learned, meaning they're assessing your current level of knowledge in a given content area. An example for this would be the AP Psychology exam or the APUSH exam in May, okay? That is assessing or reflecting on all of your knowledge that you've learned this year. An aptitude test is intended to predict, not reflect upon, but predict your ability to learn a new skill. How well can you do on solving certain types of problems? Examples of these would be the ACT and the SAT. Those are supposed to predict how well you're going to do with college-level work. Hence, this is why colleges look at those scores to weed out or put a cap upon candidates that may not be ready for the rigor or the higher ordered or higher critical thinking learning that is expected at their particular school. Or they might not be disciplined enough to do well in a college-level reading, writing, or problem-solving course. All right, let's talk about this guy named Flynn. Sound familiar? Yes, I know we heard about him in the other video. Okay, while Thurstone, Gardner, Sternberg, and Goldman, all of these guys tried to define intelligence, Flynn is known for his observation that intelligence is measured by IQ tests, but is actually increasing over time. Coined the Flynn effect. We're going to talk a little bit more about Flynn in a little bit here, but let's get back to the principles of a test for a psychological test to be acceptable, meaning an intelligence test must fulfill 3 categories. First, standardization. Second, reliability. And third, validity. We're going to talk about each one of these separately. So standardization is when the test items are piloted, meaning specific questions, let's say 1 through 50, are piloted in one group and 51 through 100 are piloted in another group. Okay? Think about what that word pilot means, right? It's a test run. Kind of like the first episode of a brand new show is the pilot. Right? And the network will say, okay, that show did really well in the ratings. We're going to approve it and go ahead and move forward with the next episode. So the items or questions are piloted on a similar population of people and norms will be established. We're going to talk more about what the heck that means in a bit. Okay, but first, norms. Norms are developed, meaning a normal score from the piloted group, let's say, is 75%, right? The most, or the average, or the median, or whatever you want to call it, is the norm. They have developed this norm by calculating the average score achieved by a particular group. And then each person's score can be compared to see how different it is from those people who have already taken the tests in the past. An AP test might be given to college freshmen as a final exam to kind of set the norms, or course exams are given to previous class to set those norms, known as the standardization sample. Okay, so an AP test that you guys take in May might be piloted on a standardization sample of whether or not some freshman college students could have been in the previous years or previous 2 or 3 years of AP psychology, right? The exam takers would look at that and take all of the scores and find out if the normal curve is essentially what they say it is, okay? So wherever the middle is, meaning the highest point, is the mean, median, and mode. We're going to shift these scores at the bottom here. So we're going to say that all these students who scored in the middle here, let's say 75% worth, we're going to shift them 1 or 2 on the scale and would make what we call these periodic tests standardized, meaning what I just described to you given to a random representative sample to reset and check the established norms, including intelligence tests whose normal score is 100. Okay, so let's look at a normal curve. This is the normal curve on standardized tests. They establish a normal distribution of the scores, right? That's the normal curve there on a tested population, a bell-shaped pattern, which we already know we call the normal bell curve results. So what I'm getting at here is, let's talk about the intelligence test, the IQ test. The normal score is 100. Right? So you're considered average if your intelligence IQ is rated at 100 points. Now, that is the same as it was in 1848 as it is in 2023. 100 is the norm. The reason why they're staying at 100 is because they've standardized the intelligence tests frequently enough, every few years, let's say. So what they find in their standardization sample is that the normal curve comes up again and again. So the mean, median, mode is the most frequent score. Let's say like 80% of all people in the population are showing that they know 80% of what's on the test. What they're going to do is, let's say 50 years ago, they would have shown that they knew 60% of the test. That means that today we're more intelligent, right? Why is the average intelligence score still 100? Well, it's because what they do with these bottom scores here is they shift them a little bit. They shift them so that 100 always stays in the center, because that is the average score. Okay, this takes us back to the Flynn effect. Now understand what is described in the restandardization shifting is due to, you could say, to the Flynn effect. Because in the past 60 years, intelligence scores have steadily risen by an average of 27 points, which we now know is a phenomenon known as the Flynn effect. There has been a rising average in intelligence on test performances, and yet the average score is still 100. Okay, this is due to the restandardization. We'll talk about that some more in class. But why do you think we're more intelligent? Is it because our genes have mutated and we are now much more intelligent species today than we were 60 years ago? Hardly, no. It's all environmental factors. Healthcare, for example, has been much more advanced than 60 years ago, right? We now have antibiotics for everything, and we get vaccinated for everything. And when we're sick at times or have infections or fevers, we have antibiotics to cure them. And we have vaccinations, and therefore we're not getting sick in a way that could kill us with these infections or fevers that used to kill us. And therefore, we could focus on our brain and mental development now. Schools are more advanced also, right? Or at least we could say more involved, and you could say better than they were 60 years ago. Plus, all of these things like nutrition is better, right? We know to take multivitamins. Proteins are widely available now, even in powder form. So we know about science and farming and nutrition so much more. It's all environmental. Okay? Next up is that a test has to be reliable. Okay? Reliability is when a test is given and it yields consistent results. So this means if on one day the test yields an average of test scores averaging, say, in the 60th percentile, but on the next day it yields an average in the 94th percentile, whoa, that's not reliable at all. We must ask, why is the scoring so much different? It needs to be assessed because it should be within a few points every time the test is given for it to be reliable. So, some of the ways to test reliability are these three ways. First, we have a split half reliability. That's when we divide the test into two equal halves and assess how consistent the scores are, meaning you give one half to one side of the room and the other half to the other side of the room. If both sides of the test are getting about the same score with different questions, then the reliability is good. Right? You're using different forms of the test to measure consistency between them. And then perhaps maybe you'll shuffle the order of the questions. That's a good way to test or retest reliability. Third up is using the same test on two occasions to measure consistencies. Meaning you give the test today and then in about 1 week under the exact same conditions you give the test again. That's test reliability. The last thing that all tests must show to show validity is that validity on a test refers to what the test is supposed to measure or predict, okay? So, for example, let me ask you something. How much do you weigh? Well, in order to find out, what are you going to do? Are you going to go measure yourself with a measuring tape or a ruler? No, that would not be a valid measurement of your weight because a tape measure is not measuring what you're wanting to assess. Okay, so we will hop on a scale, right? The scale is going to measure what we weigh. Therefore, that is a valid test. But there are two types of validity. The first one is the content, referring to the extent that a test measures a particular behavior or trait. So, is the AP Psychology exam measuring your psychology knowledge? Or do they throw in so many statistic problems and math problems that it turns into a statistics test, and therefore it's not really measuring your psychology knowledge? Predictive ability refers to the function which has to predict a particular behavior or trait. If it's actually predicting and accurate, then it's valid and reliable. The reliability of a test does not ensure validity, though. In other words, a test can be consistent without testing what it's supposed to test. So is intelligence fixed or does it change? And it kind of depends here on the two different types of intelligence that we'll be talking about. Okay, so fluid intelligence reflects information processing capabilities and reasoning and memory. Fluid intelligence tends to decline as we age because this is your ability to process new information. So think of like a 25-year-old going into an airport for the first time, like one they've never been to, okay? They're probably going to make it okay on their own, right? They're going to make it to their flight on time. They'll figure out, they know how airports work, right? They know how, or layover, what time to get there, what time to leave for themselves. But put a 75-year-old in a brand new airport, and it might be hard for them, even if they've been to millions of airports before, because they're having to process new information, digital information, right? And they may not know some of the assumptions about the things, and that's harder to do as we age. Okay, crystallized intelligence is that which has accumulated throughout our lives. Knowledge, skills, and strategies that have been learned throughout our experiences. These tend to increase throughout life, and we call it something like wisdom, right? Think of all the hard knowledge that is crystallized. Hard crystallized meaning hardened, right? Like a hard crystal, like the hard facts, those strategies that you've used your whole life. So a 70-year-old may have better crystallized intelligence than a 30-year-old because they've been processing that information over and over throughout their lifetime, okay? They will definitely be slower at it, but it definitely doesn't mean they have less intelligence. Okay, my dears, that's all I've got for you tonight. Have a great night. Bye now.